Hello. In lesson 8, we learned about the center of rotation from the origin, where we said at that point, our center of rotation as the coordinates 0 for x, 0 for y. And then sometimes you can be told to rotate our fingers from a point which is not the origin. So, how do we go about it? We can use an example here. For example, this question 1 to understand how we go about a problem like that. So in this question 1, we are told triangle ABC has the vertices which is 4, 2, then B which is 3, and then C which is 5, 6. Then you are told to rotate triangle ABC by 90 degrees clockwise about the point 2, 1. So here the center of rotation is 2, 1, and it is never 0, 0 anymore. Then you are told to find the coordinates of the triangle, the rotated one, of course. The first step, as usual, is to copy all the information we have on the board. So let me do so. So we have the original coordinates, which are for point A, this will represent x, this is y. For point B, this is x, this is y. Point C, this is x, and this is y. And then we have the center of rotation, which is 2, A for 2, and then B is 1. And then we have the angle of rotation, which we are told in the question is 9 degrees clockwise. And when I mean clockwise, this is what I mean. We should rotate that finger like this. If it wasn't clockwise, it would be like this. You move like this. The first step we need to do is we need to take these coordinates. Here, we translate them first such that now the center of rotation is kind of like is from the origin. And to do so, we use this formula here. We take the x coordinates, we subtract a, where a is this value, the first value in the center of rotation, and then we take all the values of b, and we take all the values of y, we subtract b, where b is the second value of the rotation center of rotation. So can I do that here? We said we take these x and y will now be x minus a and then y minus b. And we do have our a and b here. So now our first point a, I'll just call it again a. We know x is 4, so 4 minus a, and a is 2, so now it becomes 2. And then y is 2 here, but we know our b is 1, so it will now be 2 minus 1, which is 1. Then we do the same for b, which now becomes, we take, of course, x, which is 6, minus our 2 here, which is now 4. And then we do the same for y, which is 3, but now minus this 1, which is 2. And then we go to c and do the same. We take 5 minus this 2, because it's our a, so it becomes 5 minus 2 is 3. And then we have 6. 6 minus 1, or b, which is 5. And now we have forced these coordinates to be kind of like we are rotating from the center of or the origin, which is 0, 0. But you see, in our case, we were not told to rotate from 0, 0. We were told to rotate from this point. So we still continue. Since we were told to rotate from 9 degrees clockwise, then we apply this rule of rotation 90 degrees clockwise, where now the coordinates of x and y change to yx, but now the x becomes negative. So of course, in our new coordinates here, this is x, this is y, x, y, x, and y, like this. But then we interchange. We start with a, and the coordinates of a, which were now x, y, Now they change to yx. We can just change it like this. Now y starts and x is the second one like this. Then we go to b. We do the same. We start with y and we finish with x, and then we do the same with c, where we have 5 and 3. But you see, we said this new x's should be, which took the place of y, should be negative. So all these values on the position of y then become negative. So now from there, we go to the next step. Up to this point, this triangle is rotated for the center of rotation, which is 0, 0. So now, translate it back or to rotating back using our center of rotation, we need to translate these coordinates to our original center of rotation, which was 2, 1. And to do so, we need to take all the values of x, which are of course this one, and this one, and then all the values of y, and we add our original center of rotation values, which were 2 and 1. So we can just start with x plus a. Of course, a is 2 and then b is 1. So we start with 1, then this one was for a, and now we have 1 plus this a, which was 2. So 1 plus 2 is 3. Then we go for y plus b, and this here is negative 2, but our b is 1. So it's negative 2 plus 1 is negative 1, like this. Then we go to the second point where we have x plus n, and we know x is 6, plus a is 2. So plus a, a is 2 here, and also here is 2, so it is 2 plus 2, which is 4. And then we go to y here, which is negative 4, and here is 1. So negative 4 plus 1 is negative 3. And then we go to c, which is we have x is 5, but we have a is 2, so 5 plus 2, which is 7. And then finally you have negative 3 plus 1, which is negative 2. And that's how we rotate a finger 9 degrees clockwise from a given center of rotation. So the new coordinates we are here for A, B, and C, they become A is 3, negative 1, then B is 4, negative 3, and then C is 7, negative 2. Can we try another example? Oh, in this example too, you are told a triangle PQR has the vertices negative 1, 4, Q is to 4, and then R is 1, 7. Then, of course, plot the triangle. So this one we also need to plot in the Cartesian plane. Then rotate triangle PQR by 180 degrees about the point negative 3, 5. So center of rotation is negative 3, 5. Then plot the image of triangle PQR. And of course, write down the coordinates on the rotated triangle. So, can we start with, first of all, let's copy whatever we have on the board. So we have all these, where we have, of course, the original coordinates. Then the center of rotation is negative 3, 5. We have to rotate 180 degrees. This, of course, because it is positive, is 180 degrees clockwise. So from there, so first, let us force all the points here to be rotated from the origin, which is point 0, 0. To do so, we need to change this xy. We apply this formula where we take all the values of x, we subtract a, and all of the values of y, we subtract b, where a and b, a is negative 3, then b is 5. So, from there, our new p now will be negative 1, because this is x, and this is x for r, this is y for p, y for q, and y for r. So we start with this p here, which is negative 1, and our a is negative 3, and if we take a negative 1, minus minus 3. Now it will be 1 plus 3, which is negative 1 plus 3, which is 2. So this one is 2. And then we go to y. Y is 4. And we already know our y here is 5. So of course, 4 minus 5 is negative 1. And then we go to q, where we have 2. Then 2 minus a, but minus minus a, it will be 2. Now, it's kind of like 2 minus minus 3, which is 2 plus 3 and is 5. Yeah. And then go to this q here, where we have now y is 4. And then 4 minus 5, which is negative 1 again. Then we go to r. Then now we have 1. And this one, of course, is minus negative 3, which now becomes 1 minus minus 3, which is 1 plus 3, which is 4. And then we finish with this is 7. I hope so. Let me confirm. Yes, 7. Then 7 minus 5, which is 2. Like that. And then we have these points now kind of like rotated from the origin, but don't forget, our rotation should happen at this point. So we need to go to the next step. So when you rotate anything at 180 degrees, these coordinates of x and y, they don't change like the one we did in 9 degrees. They just remain the same as x and y, but both of them become negative like this. So we only need to add negative on all of them. So now the new coordinates, I can put them here. And I say for p, now it will be negative 2. So that x can be negative, and then negative y. But you see here it is already negative, so and this another negative, so it will now be positive 1 because negative multiplied by negative is positive. So we go to q, and then it becomes, of course, negative 5. And we have negative 1 there, multiplied by this negative y, it will be positive 1, and we have q and r. Then in r we have 4. And then 4, so it will be negative 4, and then 2 will be negative 2, of course, like that. Then, so that now we go back to our, this one is still rotated 180 degrees from the origin. So now to go back to our original center of rotation, which was negative 3, 5, now we need to apply the final formula here, where we'll take this x and y, and then each of them we add x plus a, our a, this one, and then we also had y plus b, this b here. So now our original translated coordinates will become x plus m, but we already know this is x, this is y, x, y, x and y, like this. So we start with x, of course, for p, which is negative 2, but we already know this one was also negative 3 is the a. So negative 2 plus minus negative 3, it will be negative 2 minus negative 3, which is negative 5. Then we go to 1, and our 1 here is b, our b is 5, so 1 plus 5 is 6. Then we go to q, we apply the same, q rotated will be negative 5, and we have plus minus negative 3, which will be minus 5, minus 3, which is negative 8, and then we have our 1 here, and then we have b, which is 5, so it will be 6, and then go to r, rotated, which will be negative 4 minus negative 4 plus minus 3, which will be now negative 7, because minus 4 minus 3 is negative 7. And then the last one will be negative 2. plus 5, which is b. Negative 2 plus 5 is just 3. Others become our coordinates. So these coordinates here, we have already answered our question here. Run down the coordinates of the rotated triangle we already have there. So we are remaining with plotting the translated triangle and then also the original triangle. So we can start actually by plotting this original triangle, which is negative 1, 4. So we come, yeah, we can plot it. Yeah, it is negative 1, 4 somewhere there. Then the second one is 2, 4. So 2 and 4 somewhere there. And then the last one is 1, 7. It is 1 and 7. Let me just put it somewhere there. Assume it's above them because 7 is far away and beyond the grid. Then well, now that we have been plotting all these graphs on the grid since lesson 1 all the way now we are in lesson 9, can you try to plot this translated or rotated triangle on the grid and you see if you can actually plot it yourself. If you don't get it, you can ask me any question, or where you don't understand, you can ask me on the comment section. I'll try to answer to my level best. I'll solve any question you have. And bye for now. Let us meet in the next lesson.